Hello everyone, I am Goel, Assistant Professor in the Department of ECE, Akgec Engineering College. In today's live lecture, we are going to discuss about the amplitude modulation. Let us first understand what is communication. Communication is the process of transferring any information from one point to another point. Or we can say that it is a process of conveying any information from source to destination or from transmitter to receiver. So, any flow which happens between a source and destination, that is called communication. Although system that will help in fulfilling this flow of information from source to destination is called as communication system. This information can be of any kind. This information can be a voice signal, it can be a TV signal, it can be email, it can be text, or it can be in any other form. So, the basic entity of communication is the very first is the source of information. We want to transmit this information. First, we require to convert this information into some kind of electrical signal with the help of an appropriate transducer. Okay. So, after converting the information into electrical signal, then it will be processed by the transmitter. The very important part of the transmitter is called modulator, where the processing of this information or the electrical signal will happen. So, let us understand what is modulation, why it is required in communication, and what are the different types of modulation. Then we will discuss the first type of modulation, that is amplitude modulation. The very first information that can be in the form of voice signal, email, or it can be TV signal. It is basically a low frequency baseband signal. The low frequency message signal or the information signal is also called as baseband signal that we want to transmit. This message or the baseband signal is having low frequency component. If we will talk about the voice signal in this example, then the speech or the voice signal have the maximum frequency 3.4 kilohertz. So, if we want to transmit this low frequency message signal to the receiver, then there are certain challenges. We will talk about those challenges later. So, the point is we cannot directly transmit this information or the baseband signal. So, how we can transmit this signal? We can transmit this signal with the help of a carrier signal, which is nothing but a high frequency periodic waveform. This low frequency message signal can be transmitted to a far point with the help of a high frequency periodic waveform, which is called as carrier signal. So, what is carrier signal? The carrier signal is a signal which carries the original information. Okay. Now, the question comes, how will this high frequency carrier signal will help us in transmitting this low frequency message signal, or how we can impose this low frequency message signal onto a carrier signal. We know that every signal has certain properties. Periodic signal have three properties, that is amplitude, frequency, and phase. So, by varying any one property, any one of these properties, amplitude, frequency, or phase of the carrier signal, we can impose this message signal onto this carrier signal, and then this carrier signal will help in transmitting this signal from the source to the destination. So, the modulation we can define. What is modulation? The modulation is the process of varying any one property, that is either amplitude, frequency, or phase of a high frequency periodic waveform according to the message signal is called modulation. What is modulation? Varying any one of the parameter of a high frequency carrier signal according to the message signal. Now, depending upon which property we are varying according to the message signal, it will become that kind of modulation. If we are varying amplitude of the carrier signal according to message signal, it is called as amplitude modulation. If we are varying frequency or phase of the carrier signal according to the master signal, then it is called as phase or frequency modulation. At a time, we will vary only one parameter of the carrier signal. Okay, so the modulation help us in achieving the efficient and reliable transmission of the information, that is our baseband signal, that is a low frequency signal from source to transmission. Now, let us discuss what is the need for this modulation other than transmitting the signal, low frequency master signal from source to destination. The very first important requirement of performing modulation, that it helps us in achieving the practicality of antenna. What is the meaning of practicality of antenna? It will help us in reducing the height of the antenna if we are performing wireless communication, if we are performing or if we are using wireless communication, or if we are transmitting our signal wirelessly. We know that as a general rule, the height of the antenna is proportional to the quarter of the wavelength. The wavelength is further inversely proportional to the frequency, that is C upon F, where C is the speed of the light and F is the frequency. So, the height of the antenna is inversely proportional to the frequency of the transmitting signal. It will consider the voice signal which are having very low frequency. So, it will directly transmit the baseband signal or the master signal, the height of the antenna required is very high, and that much height of the antenna may not be realizable. So, what we do in modulation, we shift the lower frequency signal to a higher frequency spectrum or the higher frequency side. So, the moment will increase the frequency, or we shift the frequency, lower frequency to higher frequency, this height of the antenna will decrease and it become realizable. So, it is the very important need of performing modulation, that is to reduce the height of the antenna. Another important requirement of the antenna is the avoid of mixing of signals and the multiplexing. What is avoid of mixing of signals? For example, if 5 students are talking to each other and they want to convey some information to another point, and if they want to convey some information to their teacher. If all of them will talk simultaneously, then no information will be received, or all the information will get mixed, because all the voice signal or the speech signal lie equal to near to each other. Okay, so what we can do, it will modulate each of the signal to a different frequency level and then transmit them simultaneously, and at the receiver we can demodulate them, then there will be no mixing of signal. So, with the help of modulation, we can modulate each signal to a new frequency, to a new higher frequency, and we can stop mixing of the signals. And this will also allow us to transmit multiple signals simultaneously, that is called multiplexing. So, with the help of modulation, multiplexing, that is the simultaneous transmission of multiple signal through a common channel, is possible. Okay. So, these are some needs of performing modulation. Now, let us categorize the types of modulation. On the basis of carrier signal that we are selecting, the modulation can be described as, or the categorized as, continuous wave modulation and the pulse wave modulation. What is continuous wave modulation and what is pulse modulation? This will depend upon the type of carrier signal that we are selecting. Continuous wave modulation will occur or will be realized with the help of selecting a high frequency periodic waveform as a carrier signal. If our carrier signal is a continuous waveform, is a continuous high frequency periodic waveform, then it will be called as continuous wave modulation, or in general term we used to say analog modulation. Okay. But if we are selecting a pulse signal as a carrier signal, then it is called as pulse modulation. Under continuous wave modulation, further we have 3 types of modulation, that is amplitude, frequency and phase modulation. As I described that what is modulation, changing any one property of this carrier signal according to the message signal. What property we can vary of this carrier signal? That is the amplitude, phase and frequency. So if we are varying the amplitude, it will become amplitude modulation. If we are varying frequency of this carrier, it will become frequency modulation. And if we are varying phase of this carrier signal according to the message signal, then it will become phase modulation. Okay. Similarly, here we can define this analog and digital modulation, where our carrier signal will be in the form of pulse signal. So here, if the amplitude of this pulse signal will vary according to the message signal, it will be called as pulse amplitude modulation, PAM. If the width of this pulse signal, this is the width of the pulse signal, will vary according to the message signal, it will be called as pulse width modulation or pulse duration modulation. And if the position of these pulses in the carrier signal, these pulses are occurring at the regular time interval. But if we will shift the position of these pulses according to the instantaneous value of the modulating signal, then it will be called as pulse position modulation. Further, we have digital modulation technique, that is pulse chord modulation, delta modulation, amplitude shift keying, frequency shift keying and phase shift keying. In today's video lecture, we are going to focus on continuous wave modulation, and under continuous wave modulation, we are going to understand in detail about the amplitude modulation. Before starting the amplitude modulation, let us discuss these two terms which are important with respect to the modulation, that is the baseband signal and the modulated signal. What is baseband signal? As I discussed in the previous slide, the baseband signal is the original message signal or the information signal that we want to transmit, which is generally a low frequency signal. So sometimes we used to say message signal, sometimes we used to say information, sometimes we used to say baseband signal, and it is also called as modulating signal. So there are, we can say we have 4 names of the information that we want to transmit: original information, message signal, baseband signal or the modulating signal. Okay. Then what is modulated signal? This baseband signal is a low frequency signal. Modulated signal is that signal or is that baseband signal where we will shift the frequency of the original signal to some higher level. The frequency of the baseband signal, when shifted to the higher frequency level after performing modulation, the output of the modulation is called as the modulated signal. So before modulation, that is our information, that is called modulating signal, and after modulation what we will get? High frequency signal, which is called as modulated signal. Okay. So now let us start with the amplitude modulation. Meanwhile, till this point, if anyone has any query, then you can ask with the help of the chat box. So let us start with the amplitude modulation, which is the very first type of the continuous wave modulation. What is amplitude modulation? As the name suggests, modulation is the process of varying any one property of the carrier according to the message signal. So what is amplitude modulation? If the amplitude of the carrier signal will vary according to the message signal, then it is called as amplitude modulation. When we are performing amplitude modulation, then the phase and the frequency of the carrier signal will remain constant. For example, here we have the waveforms. The first waveform is representing the message signal. Let us consider that this is the maximum amplitude AM of this message signal. The second waveform is representing a high frequency carrier signal. Let us consider that its maximum amplitude is AC. So which parameter of this high frequency carrier signal will vary according to the message signal? That is its amplitude. Here the amplitude, phase and frequency of this carrier signal is constant. Okay. In the modulated waveform, we can observe that the amplitude of this carrier signal is taking the shape of my message signal's amplitude. So in the modulated signal, what we are getting variation in the amplitude of the carrier signal according to the amplitude of the message signal. As the amplitude of message signal is increasing, the amplitude of this carrier signal is increasing, and as the amplitude of this massive signal is decreasing, the amplitude of this carrier signal is decreasing here. So the maximum amplitude we will get in this modulated waveform is AM plus AC. The minimum amplitude in the similar manner will become AM minus AC. Okay. So in the amplitude modulated signal, what we are getting variation in the amplitude of the carrier signal according to the amplitude of this masses signal. We have certain types of amplitude modulation. We have 4 types of amplitude modulation. The first one is double sideband full carrier modulation. The second one is double sideband suppressed carrier. The third one is single sideband suppressed carrier, and the fourth one is vestigial sideband modulation. The first one, which is double sideband with carrier, is also called as conventional amplitude modulation, that we are going to discuss in detail in today's lecture. So starting with the mathematical expression of this double sideband full carrier signal. So we have one question from the Jayaprakash, that envelope of the amplitude modulated signal contains information of massive signal. Yes, it is correct. Here we have the modulated signal. It will join the outer amplitude, or that is the trace of the amplitude. This is called envelope of the modulated signal. As the information is lying in the variation of the amplitude of the modulated signal, we can say that this envelope is containing the information part. This is correct. The envelope of the modulated signal contains the information of the masses signal. Okay, so let us start with this. Out of these 4, we have double sideband full carrier modulation that we are going to discuss in detail. So let us start with the mathematical representation of amplitude modulated signal. Till now what we have discussed that we have a low frequency massive signal that we want to transmit to a far point, but we cannot transmit it directly as it has certain challenges. So we are required a carrier signal with the help of which we can transmit this baseband signal. Okay. Now let us observe the mathematical representation of each signal that we are discussing about. The very first signal is the massive signal. Massive signal we can represent with this symbol m of t. This massive signal is imposed onto the carrier signal, let us say CT. The carrier signal we can represent, which is a high frequency periodic waveform. So let us consider CT is AC cos 2 pi FCT and MT is AM cos omega MT. When we will combine these two massive signal and the carrier signal, where the amplitude of carrier is varying according to the massive signal, we will get the modulated waveform. Okay. So if we are representing a low frequency massive signal with AM cos omega MT, where AM is the amplitude of massive signal, omega m is the angular frequency of the massive signal or the modulating signal, or we can also represent omega as 2 pi FM, where FM is the modulating frequency of the massive signal. Okay. So our expression for massive signal will become AM cos omega MT or AM cos 2 pi FMT. Similarly, we can represent the carrier signal as AC cos omega CT or AC cos 2 pi FCT, where AC is the amplitude of the carrier signal and FC is the frequency of the carrier signal, which is very high in comparison of modulating signals frequency. This is the very first condition of performing amplitude modulation, that the carrier frequency must be much greater than the frequency of the modulating signal. Okay. So when we will combine these two, how we will combine these two? As per the definition, we are required to change the amplitude, that is AC, of the carrier signal according to this massive signal MT. So what we will get? We will get, when we will impose massive signal onto the carrier signal, what we will get? AC cos omega CT was the carrier signal, in the modulated signal, the amplitude of this carrier signal will be modulated by this factor, which is mt. So we will get in the modulated signal AC plus mt cos 2 pi fct. Okay, it will take out this AC common from this out of this bracket. We will get AC 1 plus Ka mt, where Ka is the amplitude sensitivity parameter. So our standard expression for amplitude modulated signal in this case will become AC in bracket 1 plus Ka into mt cos 2 pi fct, where this part is called envelope, of the modulated signal, which is carrying the information. Okay. So in this expression, it will replace mt with the considered signal, which is am cos omega mt. What our expression will become st AC 1 plus Ka. Instead of mt, we are putting am cos 2 pi fmt. Omega m can be written as 2 pi fmt. Don't get confused between omega m or at some time it is fm. Either we can mention omega m or we can replace omega m with 2 pi fm. Okay. So we will get AC 1 plus Ka. Instead of mt, we are putting am cos 2 pi fmt cos 2 pi fct. This product of Ka into am, Ka is the amplitude sensitivity parameter, am is the amplitude of the modulating signal. This product of Ka into am we represent with another symbol, that is mu. This mu is called as modulation index. What is modulation index? We will understand in after certain slides. For now, this product of Ka into am is represented with mu, and mu is the modulation index. Okay. So the standard equation we can rewrite as St is equals to AC 1 plus mu cos 2 pi fmt into cos 2 pi fct. This is the standard equation for amplitude modulated signal. We can now let us understand the single tone representation of amplitude modulated signal, or the single tone expression for amplitude modulated signal. First, let us understand what is the meaning of single tone. The meaning of single tone AM modulation is that if we are considering only single frequency component in our master signal, the master signal we have considered in the last slide is AM cos omega mt. So there we have only one frequency component omega m, that is 2 pi fm. Okay. So if we are considering single frequency component in our master signal and then we will perform modulation, that is called as single tone AM. We can also consider multiple frequency component in our master signal, that will become multi-tone AM signal. Here single tone AM modulation is what? Single tone AM modulation is when the master signal contains only single frequency component. So let us check out what is the representation of single tone AM expression. We have the amplitude modulated signal as AC plus mt cos omega ct. Let us consider that mt is cos omega AM cos omega mt. So replacing mt with AM cos omega mt, our expression will become AC plus AM cos omega mt. Outside bracket we will get after this we will get cos omega ct. Whatever written before this cos is the amplitude part of this function cos, that is the envelope of our modulated signal. Opening this bracket, we will get the first term AC cos omega ct. The second term we will get AM into cos omega mt cos omega ct. We know the formula of 2 cos A cos B. So multiplying and divide this term with a factor of 2. Multiplying and divide this factor with a this term with a factor of 2, we will get 2 cos A cos B formula. Further rearranging this equation, we will get AC cos omega ct plus AM by 2 twice of cos omega mt cos omega ct. Now we can apply the formula 2 cos A cos B is cos of A plus B plus cos of A minus B. So our equation will become, in this case, AC cos omega ct am by 2 cos of omega c plus omega m plus cos of omega c minus omega mt. In the next line, multiplying and dividing the second term with AC, that is the amplitude of the carrier signal. Rearranging further this expression, we will get AC by 2 and AM by AC. This ratio of AM by AC we are representing in the next line with mu, that is the modulation index. So modulation index we can also define as a ratio of amplitude of master signal to the amplitude of the carrier signal. In the last expression we have seen that the modulation index is equals to Ka into Mt, mod of Ka into Mt, and the modulation index can also be defined as the ratio of the maximum amplitude of the master signal to the amplitude of the carrier signal. So replacing this ratio of Am by Ac with mu, we will get AC cos omega ct plus AC mu by 2 cos of omega c plus omega mt plus AC mu by 2 cos of omega c minus omega mt. Okay. Rearranging this expression, we will get this standard expression or the single tone expression for amplitude modulated signal. Replacing omega c with 2 pi fc and omega m with 2 pi fm, the same expression can be represented in the form of frequency of the carrier and the frequency of the modulating signal fc and fm. Okay, where the first term, if we will observe this expression, single tone expression, the first term is what? AC cos 2 pi fct. AC cos 2 pi fct is nothing but the carrier signal that we have selected. So we can mention that the first term is carrier signal. If we will observe the second term, here we are getting addition of the carrier frequency and the modulating signals frequency. So this term is called as upper sideband. What is this called as? Upper sideband. What is upper sideband? The term where we are getting the summation of carrier frequency and modulating signals frequency. The third term is called as lower sideband. Lower sideband, here we are getting the subtraction of the carrier frequency and the modulating signals frequency. So this is called as lower sideband. So in the single tone expression we have three terms. First one is the carrier, the second one is the upper sideband, and the third one is the lower sideband. Carrier does not contain any useful information about the masses signal. The masses or the information will lie in upper sideband and lower sideband. Now let us understand how we can represent this expression or how we can draw the frequency spectrum for this expression. If we want to draw the frequency spectrum of this expression, we will observe this expression. This is in the time domain. To draw the frequency spectrum, we are first required to convert this time domain expression into frequency domain expression. Actually, we can perform signal analysis in two ways. We can perform signal analysis in time domain, we can perform signal analysis in frequency domain. Time domain means where the signal's amplitude is varying with respect to time. Frequency domain means where the signal's amplitude is varying with respect to frequency. Okay. So we can also convert time domain into frequency domain, and we can also come back from frequency domain to time domain. With the help of Fourier transform, we can convert a time domain expression into a frequency domain expression, and by taking inverse Fourier transform, we can convert frequency domain expression into a time domain expression. Okay. So to draw the frequency spectrum of this signal, we are required first to convert this time domain expression into frequency domain expression. So that what we are required the frequency domain representation of this cos 2 pi fct, cos 2 pi fc plus fmt, cos 2 pi fc minus fmt. So by taking the Fourier transform of these terms, we can calculate their Fourier transform, or we can represent them in frequency domain. Here we have some useful conversion with the help of which we can directly write down the Fourier transform or the frequency domain representation of cos and sine signal. So after taking the Fourier transform of cos signal, its frequency spectrum or the frequency domain representation will come half of del f minus fc plus del f plus fc. For sine signal, it will come 1 by 2j del of f minus fc minus del of f plus fc, where delta is the impulse that exists when at t is equals to 0. For this, it will exist when f will become equals to fc. So this is the frequency domain representation of the cross signal, which is in the time domain. With the help of this, going to convert our time domain expression of single tone AM signal into frequency. With the help of the previous expression or the previous formula, now we are going to write down the frequency domain representation of this particular signal standard AM expression. The first term is AC cos 2 pi FCT. It will become 1 by 2 AC del of F minus FC plus F plus FC. Similarly, second term, when we are going to write down its frequency 1 by 4 mu times of AC del of F, यहाँ पे frequency here FC. So for once this will be subtracted from F and once it will be added to the F. Get F minus FC minus FM and F plus FC plus FM. Once it is getting added to this frequency and once it is getting added to this frequency. Similarly, we can representation. Now we can this particular expression. Amplitude is AC by if it is the frequency axis at F Sorry for the sound issue. I think it is clear now. Okay. So till this point, if anyone has any query, thank you for your feedback. So till this point, if anyone has any query, can mention in the chat box. So what we have discussed, let me brief. What we have discussed how we can draw the frequency spectrum of amplitude modulated signal. To draw the frequency spectrum of amplitude modulated signal, first we are required to convert the time domain expression that we have derived into frequency domain expression with the help of Fourier transform of cos signal. As in our expression only cos signal is existing, so we can directly with the help of Fourier transform of cos signal, we can mention the Fourier domain representation of this time domain representation. Then with the help of this we can draw the frequency spectrum. The next is transmission bandwidth. What is transmission bandwidth? When we are talking about the communication, then bandwidth is very important parameter, as the bandwidth is limited. Whatever bandwidth is available to us, we are required to work, or we are required to optimize that available bandwidth, and we are required to transmit our data within the available bandwidth only. So here, if we are performing amplitude modulation, then what amount of bandwidth is required to us, we can calculate by taking the difference between the upper sideband and the lower sideband. So upper sideband is Fc plus Fm and the lower sideband is Fc minus Fm. So difference of there will come twice of Fm. So if we are performing amplitude modulation, that what amount of bandwidth is required? It is twice of Fm. So in case of AM, the bandwidth requirement is twice of the modulating frequency. That means if the frequency of our original information is 1 kilohertz, if Fm is 1 kilohertz, then we require to transmit this 1 kilohertz data with the help of amplitude modulation is 2 kilohertz. Bandwidth will become 2 kilohertz. Okay, so twice we require the bandwidth. Modulation index, we have seen the modulation index in our expression. Modulation index is the ratio of maximum amplitude of the massive signal to the amplitude of the carrier signal. We can define modulation index as the depth of modulation index. It is also a measure, or it is a measure to the extent of which we can convert the amplitude of the carrier signal according to the massive signal. That means how much variation, maximum variation we can do in the amplitude of the carrier signal can be defined as modulation index. So in general, it is calculated by taking the ratio of maximum amplitude of the massive signal to the ratio of the carrier signal. By multiplying this ratio with 100, we can have the percentage modulation. This depth of modulation, depending upon this ratio, is of 3 types, which is under modulation, critical modulation and over modulation. What is under modulation? If the amplitude of the massive signal is lesser than the amplitude of this carrier signal, then this ratio will come out lesser than 1. It is called under modulation. So in under modulation, what we are getting? We are getting some value in the minimum amplitude. So if there is gap in the minimum amplitude, it is called under modulation. This is the way how we used to draw the under modulated waveform. What is critical modulation? If the amplitude of the massive signal is exactly equal to the amplitude of the carrier signal, then it is called as critical modulation or the ideal modulation. If we are having no gaps between the minimum amplitude of the modulated signal, it is called as critical modulation. This is the way how we used to represent a critically modulated waveform. Last one is the over modulation. What is over modulation? When the amplitude of the massive signal is more, while the carrier signal that we have considered for the transmitting of this massive signal is low, then it is called as over modulated waveform. In case of over modulation, we used to get the distortion. This is the way how we used to represent the over modulated waveform. Here what we are getting phase reversals. Why we are getting phase reversal? Because the amplitude of the information is more, but the amplitude of the carrier that we have selected is less. So before reaching to the maximum value of the amplitude of the message signal, the amplitude of the carrier signal will be reversed. So in this case, what we will get loss of information. So this condition of over modulation in case of AM should be avoided. Generally we go with this under modulated signal. The next is the calculation of power and efficiency of AM wave. How we can calculate the power of amplitude modulated waveform? The power of amplitude modulated waveform can be calculated by summing the individual power of carrier signal, upper sideband signal and lower sideband signal. So the power of AM wave is equal to the sum of power of carrier, the power of upper sideband and the power of lower sideband. What is this power? This is the amount of power we are required to transmit this modulated signal. So how we can calculate this? PT is the summation of PC, which is the carrier signal power, plus PSB, which is the power required to transmit the sidebands. We have two sidebands, upper sideband and lower sideband. Now we are going to calculate the individual power of carrier, upper and lower sideband. How we can calculate the power of carrier signal? If we are having cos or sine signal, then it is very much easier for us to calculate the power. We know the relationship between the power and the amplitude of the signal. What is the relationship? How we can calculate the average power? That is RMS square divided by R, V square RMS divided by R. What is V square RMS? Is V max by root 2 whole square divided by R. So if we are having the maximum amplitude of the message signal available to us, we can calculate the power of that particular signal. I am talking about for the carrier signal, I am talking about for those signals which are having cos or sine term in them. Okay. So if we will observe this relationship, what is the value of power? V is equals to Vm square by 2R. In our case, if we look at our first term, what is the value of maximum amplitude? That is AC. So what will be the value of carrier power? AC square by 2R. Similarly, we can calculate the power for the upper sideband and lower sideband, which will be equal to the square of the amplitude divided by twice of R. So what value of upper and lower sideband power will come? It will come AC square mu square divided by 8R. By combining these two, PC and the sideband power, we will get the transmitted power, which is to AC square by 2R plus AC square mu square by 8R plus AC square mu square by 8R. Combining all these, we will get PT is equals to PC 1 plus mu square by 2. So this is the formula of transmitting power required for the transmission of amplitude modulated signal. Here one point is to be noted, then while transmitting this signal, what we are transmitting? We are required to transmit this amplitude modulated signal. In amplitude modulated signal, the first term is carrier signal, which is containing no useful information. So but we have to transmit it because it is existing in our modulated signals expression. So there is a wastage to transmit this carrier signal. There is a wastage of power in the transmission of this carrier signal. Our information, useful information, lie in upper sideband and lower sideband only. So we can reduce this wastage of power in transmitting the carrier signal by suppressing this carrier. That is the second and the third category of amplitude modulation, which is called as double sideband suppressed carrier and single sideband suppressed carrier, where we used to suppress the carrier and then transmit the sidebands only. It will help us in saving the transmitting power. The next is the calculation of the efficiency of the AM wave. How we can calculate the efficiency of AM wave? first let us understand what is the efficiency, what is the meaning of efficiency. Efficiency is we can define the ratio of the power which is required to transmit the useful information divided by the total power required to transmit that particular signal. What is efficiency? It is the transmission of useful information in terms of power. So, our information lies in sidebands, but in case of AM, the total power we are required to transmit is including carrier as well as sideband. So, what efficiency of AM wave will become? It is the ratio of power required to transmit the sidebands divided by power required to transmit the total signal. It will become PLSB plus PUSB, as we have two sidebands, and the total power is equals to the sum of PC plus PLSB plus PUSB. So, I will put the value of PT that we have just derived in the last slide and mention the power of lower sideband and upper sideband, which is the total power of sideband, which is PC mu square by 2. We will get the efficiency as mu square divided by 2 plus mu square, where mu is the modulation index. By multiplying this parameter with 100, we will get the percentage efficiency. Now, if we want to calculate how much efficient our AM system is, that we can calculate what amount of maximum efficiency we can achieve with the help of this amplitude modulation. By putting the value of mu is equals to 1, which is the ideal modulation index or the critical modulation index, we will get the value of neta is 1 by 3, or it will become 33.33%. So, the maximum efficiency that we can achieve with the help of this amplitude modulation is only 33.33%. It indicates that this amplitude modulation system is very less efficient. Still we use it because its demodulation is very cheap and is very easy. The next is multi-tone modulation. We have discussed till now the single tone modulation. In single tone modulation, we have considered single frequency component in the message signal. What is multi-tone modulation? Where more than one frequency component in our message signal is present. So, the carrier signal will remain same, but here in message signal we will have multiple frequency component. So, if we are having a multiple frequency component present in our message signal, it will be called as multi-tone modulation. For this, we can represent the power as PT is equals to PC 1 plus M1 square plus M2 square by 2 and so on. The total transmitted power will in this case will become PC 1 plus MT square divided by 2, where MT is the total modulation index. For multi-tone, how we can calculate the total modulation index? By taking the square root of individual modulation index value of corresponding to each message signal, that is M1 square plus M2 square and so on. For this, we can also look at how we can represent the frequency spectrum of multi-tone AM signal. If these are the two message signal having the frequency component FM1 and FM2, it is M2 and it is FM2. So, its standard expression can be mentioned as AC 1 plus mu 1 cos 2 pi FM1t plus mu 2 cos 2 pi FM2t. Okay. So, in the frequency spectrum, the only change will occur, instead of having one upper sideband and one lower sideband, we will have now multiple lower sideband and upper sideband. As we are having two frequency component, so we will get two upper sidebands and two lower sidebands. The carrier will remain as it is. Okay. Now, let us discuss. We have discussed the amplitude modulation. Here we have one example. In this, we are required to calculate the carrier power, the total sideband power and the bandwidth of the AM wave, and we are required then to draw its spectrum. We are given with this expression. For this, we are required to calculate the parameter. First, all these parameters or the expression given to us. Then the next step is to write down the standard expression corresponding to the given equation. So, the standard expression for the AM signal is AC 1 plus mu cos 2 pi FMT cos 2 pi FCT. So when we will compare this standard expression with the given signal, we can calculate many parameters. Like first, it will compare the value of AC, carrier amplitude will can calculate by 2R. So by considering R as 1 ohm, we will have carrier power AC square by 2. AC is 10 volt. 10 square is 100. 100 divided by 2, we will get 50. So the power of the carrier signal will come out 50 watt. Then the total sideband power, that is PSB, we can calculate with the help of this relation, that is PC mu square by 2. The PC we have calculated 50 watt, mu is 0.5, divided by 2, we will get 6.25 watt. Power of the sideband. PSB is 6.25 watt. Bandwidth we can calculate with a will become 2 kilohertz for